Hello there, this is Fatima Garba Yusuf and you're currently watching Khaliltronics. So I've been doing some videos on phase diagrams, and you can check out the previous videos on an overview of what phase diagrams are, as well as preliminary calculations on calculating the degrees of freedom. That's the number of degrees of freedom. So in this video, I'm going to concentrate on how to calculate the number of degrees of freedom even when you're not given the phase diagram. So the question we're going to solve, as you can see, is this example where we're told that the number of degrees of freedom for an azeotropic mixture of ethanol and water in vapor liquid equilibrium is dash. So this could be typically either a subjective or an objective question, and as you can see, there's no image for the phase diagram for this system. So how do we do? So what do we do? How do we solve this? Now, if you could recall, the primary importance of the phase diagram in calculating the number of degrees of freedom is determining the number of components, the number of phases, and stuff like that, right? So how about if we take a look at this and notice that we do not need a phase diagram in order to calculate our number of degrees of freedom? And the reason is, if we can recall our equation, our Gibbs phase rule equation, where F is equal to C minus P plus N, where N is usually 2 in some unary phase diagrams, such as the one that involves water, and is 1 for some other cases. Then when we consider this, we already know that our main unknown is our number of degrees of freedom. Alright, so it's our unknown. That's what we are looking for. But then we need the value of our components, our value of P, the number of phases, and our number of independent parameters. So in this case, we're already given some information in the question. Sometimes when you're given the phase diagram itself, you're not really given much information in words. So in this case, when you're not given the phase diagram, you can look very closely at the information that is given to you. Here we were told that the number of degrees of freedom for an azeotropic mixture, we should take note of this azeotropic mixture of ethanol and water. How many components are there then? Ethanol and water, we have 2 components, right? So our C is equal to 2, and they said they are in VL equilibrium. Okay, hence our number of phases is 2, right? Our vapor and liquid phase coexisting will give us 2 phases. So you can see, even though we're not given our phase diagram, we are already given the information we needed. As for the N, because this is an azeotropic mixture and of course it's binary, our N will typically be equal to 1, not 2, as in a well-defined water unary system. So, and we're given an additional information in case we've forgotten what an azeotropic mixture is. So note that an azeotropic mixture is a mixture of substances that has the same concentration of vapor and fluid phases with constant boiling points, such as ethanol and water in the ratio 95.6 ratio 4.4. Of course, in the question we're already told that it's a mixture of ethanol and water. So for us to calculate our degree of freedom, we simply substitute our values and calculate F. So our F is equal to 2 minus 2 plus 1. Alright, that's 0 plus 1, which will give you 1 as your answer. Meanwhile, let me just show you a brief peek at what the phase diagram of a typical mixture of ethanol and water at vapor liquid equilibrium looks like. And this data was taken from Dortmund Data Bank, and it shows a plot of the temperature in Kelvin against the mole fraction of ethanol in mole per mole. As we can see from this, the concentration of ethanol increases from left to right, which is why we have pure ethanol here with 0 water and pure water here with 0 ethanol. And of course, the values here represent the mole fraction of ethanol in mole per mole. And this is the plot of the vapor, and this is what the phase diagram plot actually looks like. And you can see that even if you were given this plot, you might not really use much information from it to solve your question, and you don't really need it, because in the question you were already given a hint at the number of components, because ethanol and water were mentioned, and also the number of phases, because you were told that it's at vapor liquid equilibrium. And with those values we were able to calculate our value of F. That's our number of degrees of freedom, as you can see here. So with this, we've come to the end of this video. Like and subscribe to our channel. Check out our other tutorial videos on a range of subjects and topics, and give us your feedback. Thank you very much.